In this video, we're going to talk about what it means to solve an algebraic equation. Now remember that an equation is some sort of mathematical statement where the left side is said to be equal to something on the right side. Now in our first example, we have x minus 3 is equal to 7. Now essentially what this means is we're looking for some sort of number where when we subtract 3 from it, it's going to give us 7. Now, for most of you out there, you're going to tell me that the answer has to be 10. And you're absolutely right. 10 minus 3 does indeed equal to 7. Now, we want to look at an algebraic approach and try to figure it out using proper mathematical steps. Now, in order to do so, we have to do something called isolating for our variable. Now, what it means to isolate a variable means to get it by itself on one side of an equation. So if we look at the left side currently, we have x minus 3 is equal to 7. We want to get that minus 3 away from that x, and what we need to do is we need to do the opposite operation. So for us, the opposite of subtracting 3 is adding 3. So we're going to go ahead and we're going to add 3 to the left side. Now, what we do to one side of an equation, we will also have to do to the right side. So since I've added 3 to the left side, I'm also going to add 3 to the right side. On the left side, we have minus 3 plus 3, which will equal to 0, and they essentially cancel each other out. On the left side, or on the right side, sorry, we have 7 plus 3, which is equal to 10. So here we have x is equal to 10. Now we can check our answer by substituting our answer back into the original equation. Since we know that x is now equal to 10, we can check our answer by writing 10 minus 3 is equal to 7. We know that 10 minus 3 is equal to 7. And that's absolutely true. 7 is equal to 7. And we can say that the left-hand side, let me write this a little bit neater. The left-hand side is equal to the right-hand side. Now for the second example here, we're more or less going to do the same thing. We have x plus 6 is equal to 15. We're looking for some number that when we add 6 to it, it's going to equal to 15. Our first step here is to get that x by itself. So since we're adding 6 to x currently, what I'm going to do is I'm going to do the opposite operation, which is to subtract 6. Since I'm subtracting 6 from the left side, I will also subtract 6 from the right side. On the left side, I have positive 6 minus 6. Those will cancel each other out. And on the right side, I'll have 15 minus 6, which is equal to 9. I can check my answer once again by substituting that value of x back into my original equation, which gives me 9 plus 6 is equal to 15, which gives me 15 is equal to 15. So once again, the left-hand side is equal to the right-hand side. Let's try a couple of more complicated examples. Here we've got 2x minus 5 is equal to 9. We want to get the x by itself. So we've got a 2x minus 5 is equal to 9. We want to first isolate that 2x because they're clumped together. So first we're going to look at that minus 5. If we perform the opposite operation, so we're going to add 5, we're going to do the same thing to the right-hand side as well. We're going to add 5. those will essentially cancel each other out on the left side. And then on the right side, we have 9 plus 5, which gives us 14. Now this is where some people run into trouble. Remember that 2x essentially means that I have 2 x's, or in other words, we have 2 times x. So what we're going to do is instead of having 2 times x, we're going to now do the opposite operation of multiplication, which in this case is division. So we're going to divide the left side by 2, and then finally the right side by 2. 2x divided by 2 leaves us with x, and then 14 divided by 2 is equal to 7. Now once again, we can go ahead and check our work by substituting in 7 into our original equation. So we'll have 2 times 7 minus 5 is equal to 9. 2 times 7 is 14. Whoops. 14 minus 5 is equal to 9. And we know that 14 minus 5 is in fact 9. So once again, the left-hand side is equal to the right-hand side. The last example we'll take a look at today is negative 4x plus 3 is equal to negative 5. So in this case, we have a couple of different options. We could first move that negative 4x onto the right-hand side to make it a positive 4x, or we can just leave it on this side and isolate it on the left. I will go ahead, I'll isolate it on the left side. So right now we have negative 4x plus 3. So I need to get rid of that plus 3 by subtracting 3 from both sides. We'll have plus 3 minus 3 gives us a 0, so those cancel each other out. And then on the right side, we have negative 5 minus 3, which gives us negative 8 on the right, and we'll have a negative 4x on the left. To get rid of that negative 4x, please make sure you don't add a positive 4. Remember, this is negative 4 times x. Now the opposite of multiplying, once again, is division. We're going to go ahead and divide both sides by negative 4. Negative 4x divided by negative 4 is going to give us a positive x. And then on the right hand side, negative 8 divided by negative 4 gives us a positive 2. Now just remember that when you divide two negative numbers, we're going to end up with a positive answer. Let's check our answer one more time here. We're going to plug that 2 back into the original equation. We'll have negative 4 times 2 plus 3 should give us negative 5. So negative 4 times 2 gives me a negative 8 plus 3 is equal to negative 5. We know that negative 8 plus 3 is negative 5. So once again, the left-hand side is equal to the right-hand side.